Tips and tricks for using Desmos for the AP Calc exam. I'm going to be more focused on AB than BC, but this should translate nicely for you BC people if you haven't figured these things out. First of all, whenever they give us a function, I'm going to define that function as f of x. You might be wondering, how do I get the parentheses? Well, Shift 9 opens the parentheses, and Shift 0 closes the parentheses. You should hopefully see those on your keyboard. And then, of course, the equal sign is right next to the backspace. And you can define any function you want. So let's say I've got 2x squared. To get the square, I have to hold Shift and press 6 to get that little caret. And then if I'm still up here, it'll stay up there. So I got to press the right arrow or click down to go down. And then I could type, say, minus 3x. And let's say my function had to divide by x, like a 1 over x. I just type the division symbol, which is right next to the Shift key, along with the question mark. And now I could do anything I want with this. If I press enter, I can find f prime of x. To get prime, I use the apostrophe. That is the key right next to your enter button, which shares a space with the quotation marks. I will not use quotation marks though. And then I can graph f prime of x. For example, this tells me that the function that I defined is decreasing to the left of 1 and increasing to the right. If I zoom out, it appears it's also decreasing to the left of 0. And of course, you should realize that it's neither increasing nor decreasing at 0 because it's not included in the domain because of what I've highlighted. Another thing to know about Desmos, if I click this home button, it takes me back to that default zoom from x going from -10 to 10 and y going from -6 to 6. This is a lot like hitting zoom 6 on your TI calculators, TI-84 and such. Now, another feature, if I hold Shift and then I click, I can zoom in and out. Or if I don't click, I can roll my mouse wheel. Of course, you have a scroll pad. If I hold Shift along an axis, then I can shift just that axis. So you can play with this how you want. And then, of course, the home screen brings you back. Of course, you could just use the minus and the plus. But I think holding Shift on the axis will really help you on that X and Y axis to get a better idea what these things look like. And then, of course, if I want, I can graph f double prime. So I can look at the behaviors to determine concavity. So this tells me I'm concave up to the left of this x value right here, concave down to the right of it, stopping, of course, at 0. And then it appears I am concave up for all positive x values for this problem. And then, of course, if I wanted to be, check a derivative, I could take the derivative by hand, 4x minus 3 minus 1 over x squared. Oh my goodness. And that should be the same as the first derivative. So you can see that sits right on top. So you can also kind of use this to check derivatives to make sure things look out right. And of course, I could have taken my second derivative again. Sorry, I misspoke earlier. And I could compare that with my second derivative just to make sure I am plotting things correctly. And of course, if you change the order, it changes whether it appears black or green if they're both plotted at the same time. So that's just a quick view of that. Now, you might get asked a question like what I will type out so you're kind of familiar with this type of question. You might get asked, when is the instantaneous rate of change on the when is the instantaneous rate of change equal to the average rate of change on the interval? I'm going to write it as, I don't know, let's do 2 less than or equal t less than or equal to 5. So really on the interval 2 to 5. Okay. So how would I do that with Desmos? Well, you should hopefully be able to calculate the average rate of change. And that involves the change in y over the change in x. So f of 5 minus f of 2, that's the change in y, over f minus 2. Now, what I might want to do is I might want to graph that. Again, you could also do this on your TIs, Casios, whatever you want to do. So I could graph the line y equals 10.9. Now, that is my average rate of change in y over change in x. How do I calculate my instantaneous rate of change? I have to find the derivative. So if I graph the derivative, now I want to see where this intersects the average rate of change on that interval of 10.9. So at the point x equals 3.49546, the instantaneous rate of change is precisely 10.9. So that would be the answer I would report. I could truncate or round, in which case it's the same. So I would conclude at t, or I guess x, at x equals that, the instantaneous rate of change, I'm going to abbreviate, do not abbreviate like this on your test, do not abbreviate like this on your test. The instantaneous rate of change, or f prime of that, is equal to, and I would copy and paste that in there. Again, do not abbreviate like I've just done, do not abbreviate. This was more likely to show up on multiple choice, and you're actually probably not going to have a calculator, but if you do have a calculator, this is what you would do. So now I just got a random assortment of FRQ questions I'm going to kind of talk over. So I'm going to start with 2019 number 1, and I'm not going to show you this on your screen because I want to focus on the Desmos. So if we're looking at 2019 number 1, and that took me to the wrong place. Number 1 is the classic fish entering the lake problem, and you are bound to see a rate in, rate out. Whether you get a calculator is to be determined. So I'm going to define the functions, e to the x, and I'm just typing. So it's pi x over 6. Again, I'm using the division symbol to get the fractions. So that's the entering. Fish leave at a rate of 4 plus 2 to the 0.1 x squared. And I forgot to define this as L of x, just to be precise. So I've got both of them graphed. So the first question says, how many fish enter the lake? So again, entering is this. So that is in units of fish per day, which means if I were to take the derivative, I would get fish per day. So again, E is in units, is in fish per day. That means E prime is fish per day squared, which means the integral of E is in fish. Okay, so the first question they ask on part A is, how many fish enter the lake? That means I need the integral. So I need to integrate the function, and it wants me to go from t equals 0 to t equals 5. So I would type this. I'm going to type t's because this is what I would write on my paper to show my work. And then I would report an answer to the nearest whole number, which would be the number 153. All right, so then the next question says, what is the average number of fish that leave the lake per hour over the 5-hour period? Okay, so it wants me to find the average number of fish that leave the lake. So what I'm going to do there is, I'm going to get rid of this just to clarify. So it wants me to find the average number of fish that leave the lake. So I want an average. Whenever you want an average, that means you have to integrate. So I'm going to integrate from the interval it's specified, which was 0 to 5. And since I want leaving, I want to do leaving. So this determines how many fish have left, but I want the average number of fish that left over that 5-hour period. So I have to divide that by the change in the time, which is 5 minus 0. So anytime you see average, it's going to be of the form integral from a to b of the function all over the change in the x or t, the input values, that independent variable. So in this particular scenario, I get this number, and I would report 6.059 is the average number of fish that leave per hour. This one did not ask for units, but when I integrate, I get fish. When I divide by 5 minus 0, these numbers in the denominator have units of time or hours, so I do get fish per hour, which is the same as the thing I wanted to find the average of, which is what's the integrand for that particular problem. So now when I go to part C, it says at what time t, on the interval 0 to 8, is the greatest number of fish in the lake. So first of all, I need to figure out how many fish are in the lake. So I'm going to use a little note to get the total number at any given time. It's going to be the initial plus the integral of the rate in minus the integral of the rate out. And I do emphasize that you should keep these as two separate integrals. You can look back at past years involving like snow. Snow is falling for the whole period, but the person only gets out and starts snowing or shoveling after a certain period of time. So the lower limit of that integration on these might be different. Same goes for the upper, because you might stop allowing people to enter a line or enter a line for the escalator or enter a concert. Remember, look at all these previous examples. So to get the initial amount, they told me nothing about an initial amount. So it doesn't really matter. I don't have an initial amount. So the amount of fish at any given time will be equal to the integral of from 0 to t of entering. And notice I'm using a different letter in my integration. I want this letter here or variable to match this variable here. And this has to be any other letter known to man. Now, if you write the same letter on your test, you write t's up here and t's down here, you will not lose points. But since you're watching this video, you really shouldn't make that mistake anyway. So then I'm going to integrate from 0 to t the number of fish leaving. So again, yes, I could have these be the same integral and it'd be fine. But now this purple function tells me how many fish are in the lake at any given time on the intervals 0 to 8. If I wanted to, I could graph this just from 0 to 8. To do that, I would define the function here. I would write a of x, and then I would use the curly braces. So holding shift, and these are the buttons right above the quotations and the enter button. And I could say go 0 less than or equal x less than or equal 8. And now I'm graphing it just on the interval that it cares about. But again, you could graph the whole thing. Doesn't really matter. I'm looking for a maximum. So I can see that it happens right there. So boom, I'm technically done. What do I do if this isn't a calculator problem? Well, I take the derivative of this function. It's going to get mad at me because a prime of x is equal to something, but I'm going to write what it's actually equal to. It's equal to e, I'm going to actually write it as a function of t. So it's e of t, the upper limit right here, times the derivative of t, which is times 1, minus e of 0, that's the lower limit, times the derivative of 0, which is derivative of constant 0. So really, a prime of t is e of t minus L of t. And I will show you that that is in fact the case. So here's e of x minus L of x graphed, and that is going to be the same as a prime of x, which you can see just popped right on top. Okay. So if I had to figure out where this thing had a max or a min, I look for critical points, which means I take the derivative of this, which is now the only thing shown, and I figure out where this thing equals 0. Well, it equals 0 on the interval at only one place. And what do you know? That location corresponds to the max. It's the exact same coordinate. So just understand that when you want to find a max or a min for these rate problems, you're going to do what's called equating the rate, which amounts to setting these two equal to each other. If I set these equal to each other, I should have got a vertical line. Desmos is mad at me, so I'm just going to let it go. I should have just gotten these zeros, but that's okay. Now, your teacher should have shown you how to make a table, or I will refer you to the table that is on the answer key. They just make a table, and again, that C is the same number we got. It might be rounded slightly differently. And then let's talk about the last one. It says, is the rate of change in the number of fish increasing or decreasing at a particular time? So I read that sentence, and let me just show you. It says number of fish. So that immediately says, oh, I need to integrate these functions that they gave me because these functions were in terms of fish per hour. So if I integrate these functions, I'm in fish. Okay, so that's fish. But I see the phrase rate of change, so I think derivative. Okay, so derivative of integral just means the functions that I have because this said integrate. This means take the derivative. Derivative of integral means you're right back to the functions you started with. It says, so is the function that I started with increasing or decreasing? Well, how do I find if something's increasing or decreasing? I take the derivative. So all I really need to do is entering at the time 5 minus leaving at the time 5. And again, it's the derivative because of what I just said. So that gives you a negative number. Since that's negative, fish are entering at a rate slower than they're leaving. They're leaving quicker, which means the rate of change in the number of fish is decreasing. So that was the first one I wanted to look at with you, just kind of talk about. The next one right here, 2022 number 2. So we got that pulled up. And we're going to go to Desmos, and I'm going to type all these functions in. All right. There we go. So it tells us f of x equals ln of x plus 3. G of x equals x to the fourth plus 2x cubed. So play around, make sure you can type these in. If you can't, well, try to figure out. Ask your teacher, or maybe leave a comment. It says find the area enclosed by these graphs. So again, I'm pressing the home button, so now I got a nice zoom. It looks like the purple one, f is on top of g. So I'm going to integrate f of x minus g of x. I need to close this in parentheses or Desmos gets mad. And I need to figure out where I integrate from. So I'm going to integrate from -2 to this number. Notice I'm going to select that number, Control C to copy, and going from -2 to that. So if I do that, boom, I've got my answer. So what do I write down on my test? I write down this. If I use my calculator like a TI, I'm going to write down as many numbers as I see. But that's all it's really looking for. So the next one, and again, make sure you write down 3.603 or 3.604 if you choose to round based on that. Truncate, it's really hard to mess up though. The next one, it says the vertical distance between the graphs of f and g is given by the function h. Is h increasing or decreasing? So I really just need to find h prime of -0.5. So again, I would define my function h, which says is the distance between the functions, which is f minus g. And I just need to find h prime. So again, h apostrophe, and I plug in a -0.5. All right, the next one, it says the region enclosed by f and g is the base of a solid cross sections perpendicular to the x-axis. So I need to find the distance from top to bottom, which, hey, that happens to be h from the previous problem. So there's h, which means my area function is just that function squared. I don't need to visualize these things anymore. So then I just need to, volume is equal to the integral of area. So I'm going to integrate area. And I'm going to go from -2 up to that previous value. And poof, I get an answer. So that's fun. And then the last question is really a question by hand to work out. I'll let you refer to the answer key to see that. Desmos, you're going to type in just like you would any calculator. Looks like I wanted to look at 2023 Part C. I guess let's pull it up here first. Sorry for making the screen go crazy. Part C, it says the rate of flow of gasoline can be given by this. Using this model, find the average rate of flow. So again, I just want to show you what that looks like to remind you how to do average. So remember, I can delete all. So the function they gave me, I guess I can define it in terms of t. I always just use x. That's just my go-to habit. Parentheses, get the division sign so it looks exactly like it. X over 500 minus the fact that I'm using x's instead of t's. Cosine of something squared, and that something is t over 120, and I get it to look like that. So it says find the average value on the interval 0 to 150. So again, I'm going to integrate from 0 to 150, the function they gave me, and I'm going to divide that all by 150 minus 0. So this is the setup they want to see, and now I have the answer. All right, next one I wanted to look at was 2023 number 2. So let's take a look at 2023 number 2. All right, I guess I've got to show it to you. All right, so I'll let you pull this one up. They've given me velocity, and it's asking me a series of questions. All right, so clear all this. Can't see my function. So they've given me velocity. They call it v of t. I'm going to call it v of x. 2.38 e to the -0.02 t or x. Sine of pi. Pi is pi. And I guess I should have said if you pull up the keyboard down here, you can find anything else you're looking for that maybe I haven't explicitly told you. So there's everything you need and more down there. But I always keep that hidden. So it gives me velocity. It says find all times when the person changes directions on the interval 0 to 90. So really, I just need to focus my window on a particular area. Again, I could define this x going from 0 to 90. So there's my only answer. To change directions means your velocity needs to be 0 at that point, and you need to change signs in velocity. So this is going from positive to negative there. So that's my one location. The next one, so t equals 56, it says find acceleration at 60. So on my paper, I am writing a of t equals v prime of t. That's what I'm writing on my paper. In fact, it doesn't hurt to show that right here. It says find it at 60. So I want a of 60. Poof, Desmos did it for me. Thank you, Desmos. I love you. Pay me, please. The next one says find the distance between his position at time t equals 20 and his position at time t equals 80. All right. And what did it do? Okay, so there we go. So to find position, remember that you would integrate. So given velocity, derivative gives you acceleration, integral gives you position. So if I want to find where his position is at 20 and 80, I would integrate from 20 to 80, v of t dt. By the way, there's my answer, but I want to emphasize that this is equal to x of 80 minus x of 20, which is precisely what it's asking. It wants me to find what is the distance between his position at these two given times, which is that, and then you're done. Last question says find the total distance traveled on the given interval, 0 to 90. So I would integrate from 0 to 90. To do absolute value, I'm going to hold shift and hit the button directly above enter on the right. And then I'm going to type my function v of x, or I could type v of t, close it, dt, and poof, you've got your answer. Let's see, what was the last one I wanted to look at? 2024, number 2. More or less all the same stuff. Find acceleration. That's just was going to be me talking about derivative. Find when it's at rest. Find where this original function equals 0, which is getting the intercepts. We found that. Yeah, nothing really here to report. I will talk about part C just to kind of refresh your memory and get you in the zone. Part C asks us to find a position at a given time. So they gave me the position was given by this function. They always give us unnecessarily complicated things to type in so we can mess up. So they told me x of 1 equals negative 3, and they want me to find the position at 4. So this is just me typing what I need to do. So recall, integral of velocity is equal to position. So the integral of from 1 to 4 would be equal to x of 4 minus x of 1. So rearranging to solve this for x of 4 means that x of 4 is equal to x of 1. I'm going to add the x of 1 over, plus the integral from 1 to 4 of v of t dt. Okay, so that's what I'm after. That's my answer. Why did it not do it? It's not integrating. This should be a number. Oh, I got to type what x of 1 is. Silly me. Boom, there's my answer. So, moral of the story. Let's say they wanted you to find the position at a different time. Let's say they wanted at negative 7. So I would still do that initial condition plus the integral from where I know it, which is t equals 1, to where I want to find it, which is negative 7, and I would still do the integral of position. Now, some of you may have been taught that you should do negative 3 minus the integral negative 7 to 1, so you maintain that sense of above the x-axis is positive, below is negative, but you'll see that both the line 5 and line 6 give you the same result. If you always just go with where you started, what you know the position to be, plus the integral from the time you started, you always put the time you started down here and a plus, it'll always work out, and where you want to find the position at top, this one is flawless. If you want to use that concept of, okay, I'm going to the left, so I've got to do a minus, whatever floats your boat. So thank you very much for watching, and good luck on your AP test.